Okay, so today we're going to talk about something called standard form of the quadratic, and then tomorrow we'll talk about something called intercept form. Hey, Chase, can you put that away? I'm going to be real curious and looking at the whole class. I want to be focused on my class. Alex gets mad when I don't pay him enough attention. Just joking, Alex. Okay, here's what standard form looks like, and you probably have seen this before, something like this in Algebra 1. I'll do function notation. F of x, or y, equals ax squared plus bx plus c. Does that look familiar? Maybe? No? Okay, so we're coming from different places. That's okay. Probably the most common place I think you go into this in Algebra 1 is maybe when you're factoring. So you factor a lot of trinomials that look like that, and then you might get into the solve by factoring, which we are going to do in chapter 3. So we will go back and review all that part. But we're going to be focused in chapter 2 just about graphing this quadratic. So remember yesterday we said what does it mean for a function to be quadratic? It has an x squared in it, or a variable that's squared. And here we can clearly see it, vx is being squared. You can also have regular x's, but as long as you have 1x squared, it's automatically a quadratic function. So we also know from yesterday's notes that anytime it's a quadratic function, we know what the shape of the graph is going to be. It's going to be a parabola, right? Hands down, everybody's graphing a parabola for this. Don't graph me any v's if it's quadratic, or lines, please. Okay. But the big difference here is it's not like the vertex form. It doesn't have a, h, and k, where h and k were the vertex. So I don't know where the vertex is. That's a pretty important part of my parabola, right? That's where I started everything. So we're going to investigate what is the vertex, what is the h, or what is the k, and we're going to do that by doing some fun algebra with vertex form. So here's vertex form from yesterday. F of x equals a times x minus h squared plus k. And I love vertex form because I can just pull out my vertex and use my vertical stretch and I got a graph, right? What does it mean right there when we square something in math? If you square a value, Morgan, what are you doing? Multiply it by itself. So would you agree we could expand this? This is a times x minus h times x minus h plus k. That's really the same thing. Multiply by itself. Okay. Now we're going to multiply x minus h times x minus h. So I'm going to do this. This is a little bit of middle work right here. That would be what? X squared minus xh minus xh and then plus h squared. Take a minute to look that over. I would call that FOILing. First, outside, inside, last, or distribution. Got 4 terms because it's a binomial times a binomial. Okay. And then we do have 2 like terms, right? The xh's. So we could say that this is really a times x squared. How many xh's do we have? 2 that are negative. So this is negative 2xh plus h squared. Oops, forgot my square. And then plus k on the outside. Is everybody okay with my algebra so far? It's weird because there's no numbers. But that's okay. Okay, so what would you do next? What's left to work out? Distribute the a. I heard someone say very softly under their breath. We'll distribute the a to all 3 terms right there, right? So this is ax squared minus 2xha, however you want to do it, plus ah squared plus k. I don't distribute the a to the k because it's outside the parentheses. Okay. Now, do you have any other like terms? No, not really, right? So that's probably as good as it gets. I've expanded it as far as it could go. Okay. So now what we're going to do is we're going to compare it to standard form. Okay. When I compare it to standard form, notice the first terms. They're the same, aren't they? Ax squared and ax squared. Okay, so A in standard form is just like the A in vertex form. If it's negative, we know our parabola is going to open down. If it's a number bigger than 1, it's going to be a vertical stretch. If it's a number between 0 and 1, the absolute value is going to be a vertical shrink. So A is the same. And we maybe noticed that before. They share A in common, right? So it didn't change. It's the same A. All right. Look for, in this one, any term that has an X in it. It's this one, right? 2xha. Or sorry, negative 2xha. And that's supposed to match up with any term in standard form that also has an X. That would be the bx. Okay, so I'm going to put these two things together in an equation. They're supposed to be the same thing. This is just vertex form expanded, and then it should match up with my standard form. So this is saying that bx is the same thing as negative 2xha. A lot of letters there. But remember, I was sad about standard form because I was missing my h and my k. Now look at the right side of that equation. It has an h in it. So if I solve to get h all by itself, I'll know what h is equal to in the parameters of standard form. So h right here is getting multiplied by negative 2, x, and a. How do you undo multiplication? Divide. So let's just divide it by negative 2xa. Divide by negative 2xa. On both sides. The beauty of algebra here. We don't need numbers. Okay, the negative 2 cancels, the x's cancels, the a's cancel, so I just have h equals. And then over here, only the x cancels. So now I know that h, the x-coordinate of my vertex, in standard form is negative b over 2a. You'll often hear me say the opposite of b over 2a. The reason why I say opposite and not negative is sometimes people think then it always has to be negative, but it just means change the sign. So I always say the opposite of b over 2a. Okay, so let's think back to our standard form right here. Ax squared plus bx plus c. If we want to find the vertex, back in vertex form, we would have said hk. Now we know h is opposite b over 2a. So unfortunately, you can't just look at the numbers in standard form and say, oh, that's a vertex. You have to do a little calculation. Opposite b divided by 2a. Now, k is a little bit trickier. So this is what I'll say for k. If you knew what x was in a function, how would you find y? If you knew x, how would you find y? What do you mean reverse? Well, like what if I knew x was 5 in that function? What's that? What do you mean solve?
X is 5 and
how would you do that? Substitute, right? If you know X, how do you find Y? You just plug it in and work it out? Are we okay with that? Okay. I'm getting a lot of people who aren't even like looking at me, so I just want to make sure we're okay. We're okay? Okay. If you know X is the opposite of B over 2A, just plug that in and you'll have Y. So I'm going to use function notation, which some people don't like, but I'm going to do it anyway. F of negative B over 2A. I'm going to write this in my own words. For the vertex, step 1. H equals the opposite of B over 2A. Do that work. Plug those numbers in. Step 2. What does that whole function notation thing mean? Plug it in to get Y. You'll have a regular number. It won't look like the opposite of B over 2A anymore. It'll be a number. You just plug that number in. Then you get your Y. You have your whole vertex. Okay, so if you have your vertex, then you also have your axis of symmetry. Yesterday we said X equals H, but now we'll just say X equals opposite of B over 2A. You won't have to recalculate this. If you've already done your vertex work, you're just going to put the number there, right? So if you find out the opposite of B over 2A is equal to 5, then you just know your axis of symmetry is X equals 5. It looks worse now than it really is. Okay, and we could do domain and range. We'll look at increasing and decreasing as well. But there's one extra thing that I'm going to add to standard form. Okay, and that is going to be the y-intercept. The y-intercept is super easy to find in standard form. So the vertex is really easy to find in vertex form. HK. In standard form, the y-intercept is there. What's true about all points on the y-axis, if you think about their x's and their y's? Every single point on the y-axis has, it's got x equal to 0, right? So that you don't go left or right, you stay on the y-axis. So if you wanted to manually find the y-intercept for this standard form, you would plug 0 in for x. I'll do it one time and then I'll never do it again for this particular standard form. So f of 0 is a times 0 squared plus b times 0 plus c. If I plug 0 in for x, what happens to those first two terms every single time?
They disappear.
They disappear. They turn into zeros. So what's your y-intercept every single time?
C.
0 plus 0, this one didn't disappear, plus c. So f of 0 is always equal to c. I don't even have to do that work every time, plug 0 in for x. I just know my y-intercept happens at 0c. Every single time. Now, what do I like about that in terms of graphing? If I find my vertex and my vertex isn't on the y-axis, I can easily just spot my y-intercept as c, plot that point on my y-axis, reflect it over my axis of symmetry, and I got 3 nice points I can use to make my u. So I can still use my vertical stretch and shrink, or I can default to my y-intercepts, okay, as extra points. They're easy to find. Let's do an example of graphing. So let's put this stuff together. You should definitely have these 3 things in your notes. And these 3 things go with f of x equals ax squared plus bx plus c. So we're using the a's, b's, and c's to get those values. Okay. So that's something you should definitely know. The stuff on the other side, the algebra, I'll never really ask you to repeat again, but it's nice for us to see where it all came from. Okay, here's our first example. If you want to write these directions down in your notebook, you can. You can also like pull out your gold sheet. These are the same things I want you to find on tonight's homework. The vertex, the axis of symmetry, the domain, the range, the increasing, the decreasing. The only thing is I've added y-intercept. I didn't ask you to find the y-intercept yesterday. And then we're going to do f of x equals 1/2 x squared minus 2x minus 1. Okay, so I think I did this yesterday where I like wrote the A, H, and K like the vertex form above. So if you need help identifying like what's going to be your A's, B's, and C's, you can always write like this looks like standard form. So this is ax squared plus bx plus c. Okay. And depending on your comfort level, some people would benefit from like off to the side writing a equals 1/2, b equals -2, c equals -1. So if you want to do that, you can. All right, remember, looking at this, none of these numbers are my vertex. Please don't tell me my vertex is at 2, -1. It is not. This is not vertex form. So we're going to have to do some work to find our vertex. Okay, to get the first coordinate of our vertex, remember our h. We're going to do the opposite of b over 2a. So looking at our equation, what is the opposite of b? Positive 2. And divide by 2 times a. A is 1/2. Do your denominator multiplication first. 2 times 1/2 is 1. So my h coordinate is 2. It's really not a bad calculation. You do have to know and study opposite of b over 2a. Well, if I know the h value is 2, how will I get the k value? Plug it back in. So I'm basically going to do f of 2 is equal to 1/2 times 2 squared minus 2 times 2 minus 1. Okay, so I'm just plugging it in for all the x's. Now, I would try doing as many of these as I can without a calculator and focus on your order of operations. If you do like using a calculator, I would do it both ways and then kind of like verify that your mental math or your hand math matches your calculator math so you know you're putting it into your calculator correctly. A lot of times I get people right here on this first term who violate PEMDAS. They're going to multiply 1/2 by 2 and say 1 and then square it. But by the order of operations, you got to do the exponent first. So 2 squared is 4. And then we're doing 1/2 times 4 is 2 minus 4 minus 1. So what do we get? -3? Okay. So voila, I have a vertex. How nice. If I have a vertex, I also know what? The axis of symmetry. My axis of symmetry is? Careful? Careful? X equals 2. Gotta be picky. 2 is not an okay answer. It's gotta be x equals 2. Even when we say it verbally. So we know. Okay, now remember, we could, and I will here in a minute, do vertical stretch and shrink. But because my vertex isn't on the y-axis, I could also just figure out what my y-intercept is. What is my y-intercept? -1. You're just looking at the value of c. So c is always the value of the y-intercept. The y-intercept is written as an ordered pair, 0, -1. So I could plot that point right there at -1. And that's 2 away from the axis of symmetry, so I could reflect it over the axis of symmetry. And at 4, -1, I also have a point. And then I could draw my parabola. That's acceptable. I'm fine with that. These are actual points on the graph. We could have also graphed by using the fact that A is 1/2. So that's a vertical shrink. So once I had my vertex at 2, -3, I could have come over here to my parent graph and vertically shrink all my y values by 1/2. So if I go right 1, I would only go up 1/2. So I'll go right 1 and up 1/2. So I'm at like -2.5. Left 1 and up 1/2. I'm at like -2.5. If I wanted to do an extra point, I would do, like on my parent graph, I normally go right 2 and up 4. But I have to shrink that by 1/2. So instead of going up 4, I'll only go up 2. So if I go right 2, then I would go up 2, and I'm matching that point for -1. Or I could go left 2 and up 2, and I'm matching my y-intercept. So if you're using the vertical shrink, or you're using the y-intercept and reflecting it, you're going to come up with the same shape. Yes, sir. The slope? Is that what you asked? Okay, the A value is the same. We decided on the previous slide. So remember back here when I did all this algebra, right? We decided at the very end of all of this that ax squared was the same in both. So A is still the same transformation that it was yesterday. If it's negative, it's going to reflect your graph. If its absolute value is greater than 1, it's going to be a vertical stretch. And if its absolute value is less than 1 but greater than 0, it's going to be vertical shrink. Okay. Now, I would caution you to call it slope. I will not call it slope in quadratics because quadratics don't have constant slope. Absolute values, we were able to like keep that slope constant because they're just straight lines. So are you okay with why it's a vertical shrink? Because it's 1/2. And then are you having trouble with putting those points on? So I answered your question. Okay. So the one thing I want to be real careful of there is you cannot at this moment go up 1/2. We could do that with a V. We cannot do that with a U. Okay. If we went up 1 and over 2, we would be outside of the parabola. That's not a point. Because if you go up 1/2, you're saying it had constant slope for 2 units, and it doesn't. That slope of 1/2 only works for the first one. Okay, what else do we need to do? Domain and range? Domain should be like a free giveaway. If you're missing domain on my quizzes and tests, I don't know what to tell you. Should be x equals all real numbers. Practice your double-sided R. It's fun. Okay. Range, you just got to look at your graph. If you graph it first, it'll be really easy. These are going to be y's that are greater than or equal to -3. The lowest y value is -3. Since you do have a point there at the minimum, you want to include the -3. So you have the or equals to. Okay. And then we also want to do increasing and decreasing. So I'll give you, about 20 seconds here if you want to decide which side is increasing, which side is decreasing, and how will you write your little inequality for that. So I'll give you a moment to think about that. Remember your parabola is split through the middle, right? Axis of symmetry. You have two sides to the axis of symmetry, the left side and the right side. The less than 2's and the greater than 2's. Follow with your finger. What's your graph doing on the left side? Decreasing. So we'll say x is less than 2. What's the graph doing on the right side? Increasing. So x is greater than 2. At x equals 2, the axis of symmetry, it is not increasing or decreasing. It's turning around. Okay, so that's its turning point. Okay. Any questions? Okay, so you're going to practice standard form tonight. I think it's going to feel like, to me, standard form always feels like more work because you actually have to do the opposite of b over 2a, and that's like more work than just saying hk from the picture or from the equation. So kind of be aware of that, but you definitely want to practice it. Opposite of b over 2a is something that you'll use in a lot of your different math classes. Okay, I've got a word problem on the board. Glorious word problems. You probably want to have a calculator out for this one because look at your coefficients. Small decimals, right? Or lots of decimals. And I'm going to give you a chance to kind of like read through and try to make sense of it with your group. I might encourage you to first draw a picture to help you understand what's happening. It would be a very easy picture to draw in about 10 seconds. Don't make it too detailed. So I'll give you a little bit of time, see if you can come up with a plan. There's my softball player. She hits a ball. So I guess she's batting, huh? Her bat. Okay. Hits it. Is that what a ball does? Something like that? Can you imagine it? Can you see it? When I go to Werner Park, all I see are all the beautiful parabolas. Okay, when they hit the balls, throw the balls. Okay. That looks like what kind of parabola? A parabola that opens down. Notice our model has a negative in front, and it's got this really, really small value of a, which think about that. When the a value is really, really close to 0, you're vertically shrinking your parabola, and it has nowhere to go but out. So it's really, really wide. Okay, so this is modeled by that function. X is the distance from home plate. Y is the height of the ball. Okay, so we'll say distance. Here we can say height. What's the highest point the ball is going to be at? Can you see it in your picture? And Isabella said it's at the vertex. So we're going to need to find a vertex. Do you know how to find the vertex? This is A. This is B. This is C. So I heard someone say negative B over 2 times A. Now, be real careful with this. If you're going to do this all at once in your calculator, then you have to tell the calculator to do like the denominator first, so you'd have to protect it with its own parentheses. If you don't put parentheses around 2 times negative 0.005, then it will divide by 2 and multiply, not divide and divide. Okay. So if you're going to type that in, make sure that you're very, very careful about that. So I'm going to type mine in. See if you can type yours into your calculator and get the same answer. I get 212.7. Am I agreeing? I'm thinking I might have put a decimal in the wrong spot because that's like a really big number. What's that? You didn't get the 5.31 times 10 to the negative 5th in your calculators? Right. Oh, I hate your calculator on your cell phone. I won't even talk about it. Okay, well that's 212.7, but that's H, which is how far away it is. So if we want to know its max height, we still have to plug it in, right? So we would do y equals negative 0.005. Oops, forgot a 5, a 0. 0.005 times 212.7 squared. Is it minus? I can't see my screen. Plus 0.2127, 212.7, is it plus 3? Negative 0.005. We'll see if I made a decimal mistake, if this answer even makes sense. Squared plus 0.2127 times 212.7 plus 3. Oh, I got 25.6. Are these in feet? Yes. Okay, so when the ball is 212.7 feet away from the batter, then the ball is 25.6 feet in the air. So to answer the question, what's the highest point the ball will reach? 25.6 feet. So if you're ever working a problem that's quadratic and it's asking about mins and maxes, you want to do like Isabella did and think about mins and maxes have it at the vertex, right? That's where you're going to find it. So if you're in vertex form, pull out your HK. If you're in standard form, do opposite of B over 2A and plug it back in if you need to.
So I understand we're talking about like I understand
Yes.
that, but why? So we got the 212.7. Why is that the distance and not the height?
Because this is the H or the X coordinate of your vertex, which that's horizontal distance. Yeah. But if it asks like when, like how far away will the ball be from the batter when it reaches its max height, then we would answer 212. Okay. Okay, so I'm going to leave it at that, just kind of like putting that idea out there about the vertex being the min or the max. You do have a homework assignment. Okay, notice that I think it's the first 4 or 5 problems that you're going to be graphing. So you want to do vertex, axis of symmetry, domain and range, increasing, decreasing, y-intercept. I like this meme even though I don't like this. Graphing is my favorite, or there needs to be an apostrophe there, but whatever. Pulled it from the internet. If you need another piece of graph paper, I have some up on the cart at the front. If you didn't use your graph paper yesterday, you could use it today.